Circular queue. So normal queue is we are inserting an element through one end and deleting the element from the other end. If suppose we are inserting 4 5 6 3 9 means, so 4 is first inserted, which is pointed by the both front and rear. After the insertion of 5, the rear is incremented. Then 6 3 9, now the rear is pointing to the 9. If you are deleting 4 5 6 3, so when the 4 is deleted, front is incremented to 1, and 5 6 3, in the sense all those elements are deleted, the front is now pointing to the 4. After the insertion of 1, we don't have the space at all, because in the normal queue, once the rear enters the size of the array, we cannot insert in any element. So the circular queue is reused to find out whether any space is present after the deletion of elements in the queue while the rear is entering the last element. So in order to include those elements at the first, because here we are having 4 spaces are free, only the 9 is present. In order to use the other 4 spaces, we are using the circular queue. We need to make whether the rear is entering at the end of the queue, in the sense that needs to the point to the first one if the element is not there. That is the circular queue. This is also following the FIFO principle. Is a linear queue that behaves as if the end of the position of the queue is connected to the starting position. It is also known as the ring buffer. So the 2 pointers front and rear 0 to n. If the maximum size is reached n minus 1, it needs to go back to the 0. The complexity of the circular queue is O of 1. Here the size is 5. So 45, in the sense, starts from 0. 0 starts from the upper level. So 45 is inserted. Front is pointing to the 45 and rear is also pointing to the 45. And the insertion of 11, which increase the rear value as 1, and 57, 23, 81, 57, the rear is pointing to the 4th position. So overflow condition is reached because r plus 1 mod n, which identifies the last position of the queue, if it is equal to f, means there is no element deleted from the queue, that is overflow. We cannot insert 32, but we can delete 45. So delete 45, in the sense front is incremented. Then delete 11, front now is pointing to 23, and 23 81 is deleted. Now front is pointing to 57. If now we are inserting 29, means that the rear needs to point to the first one, because the 0th position is empty now. So that rear needs to point to r plus 1 mod n, in the sense r value is 4. 4 plus 1 is 5. 5 mod 5 is 0. Now the rear is pointing to 0. If we are deleting 57, means the front is also pointing to 0 now. So not only making the front and rear to 0 for the insertion, for the deletion also we need to make the front pointing to 0. So after deleting the 29, the queue will become empty. That leads to the underflow condition. If you are enqueuing, in the sense the 17 is enqueued, inserted, if r and f and r is 0 now, because we are deleting the 29. So we have deleted. So 17 is inserted into the 0th position, and then 19 is inserted. So r now pointing to 19 and f is pointing to 17. So circular queue implementation, in the sense, as such, what you have seen in the queue using array, one thing is if it is empty, or if it is the size is reached by the rear, means we need to make that position is pointing to 0. So front and rear is equal to 0 and front is not equal to minus 1, means there is only one element. So the rear is greater than front, means the number of elements present in the queue is rear minus front plus 1, and the maximum size of the queue is number 7. For example, if rear is pointing to 4 and the front is pointing to 1, the rear is greater than 1, so we need to make r minus f plus 1 is 4 minus 1 plus 1, 4 elements were there. So this is the circular queue implementation. Front is now pointing to E and rear is pointing to the fourth position. The maximum size is 7. E is the elements and G is the garbage. No elements present in the 0th position, 5th and 6th position. If R is greater than F means number of elements is R minus F plus 1, 4 minus 1, 3 plus 1 is 4. If front is greater than rear, for example, the elements are present in the first position and the third position. So in the second position there is no element in the sense the maximum size is equal to front minus rear minus 1, maximum size minus front minus rear plus 1. So here 7 minus 3 minus 1 plus 1, which is 6. So number of elements present. So if the front is greater than rear, here the rear is greater than front and the here is front is greater than rear. Operations as such in the previous one, NQ, DQ, front and rear. So first the NQ operation, check verify whether the queue is empty. If it is empty, set to 0 and rear is equal to rear plus 1 mod n. For the insertion of new element, rear with the position of the rear in the queue is inserted. For the DQ, verify underflow condition. If it is true, delete the element from the front and front now is set as front plus 1 mod n. And the front and rear is same means both the things are only one element present in the queue. Thus the front and rear is equal to minus 1. The application of circular queue, memory management, because the processor are stored or processed in this demo of circular queue only. If the old process are removed for the execution and the new process added to the queue and the unused memory locations post process DQ are utilized using the circular queues and the traffic system, then CPU scheduling. These are all the applications of circular queue. For the implementation, we need to make front minus 1 and rear minus 1. If it is full in the sense, front and rear is equal, front 0 and rear is equal to size minus 1. This is empty in the sense, front is minus 1. That's it. For the NQ, verify is full and then if front is equal to minus 1, make it as front 0 and rear is equal to rear plus 1 mod size. In the rear element, we are inserting the item. And for the DQ, verify is empty. If it is not empty, items of front, if front is equal to rear, which means that there is no element at all, front and rear is minus 1. Otherwise, front is equal to front plus 1 mod size. For the display operations, from front to rear, we need to display the element if it is not empty. So this here DQ in the sense this is underflow condition because there is no element at all. NQ 1, 2, 3, 4, 5 present in the queue and the size of the queue is NQ 6 in the sense 1, 2, 3, 4, 5, 6 is there. For the DQ in the sense 1 is deleted. For the NQ of 7 means 1 is inserted. So after the maximum size is reached, rear is pointing to the 0th position. So this is the implementation of circular queue. Here if the maximum size is reached and in the previous elements are not at all filled means not at all used by the elements means we can make use of that. That is a circular queue. Once 0 or the number size of the elements are reached, we need to make that pointer is points to the 0 if that element is not there. Otherwise we need to wait for that. So there is lots of condition to verify whether SMT is full. This is the implementation of circular queue. The processors in the CPU is working based on this condition only because if more number of jobs are present in the queue, one of the jobs are used. If the jobs are used based on the condition, we can insert some more jobs for the processing of CPU. And the applications include CPU scheduling and the traffic system, because in the traffic system if no one is in the traffic in the sense the new thing which is used which is comes on the traffic system that needs to be added. These are all the applications. So the main difference between the normal queue and the circular queue is we can make use of the empty elements in the queue. Otherwise, in the normal queue, we cannot make use of the empty elements. If the rear is reached the size of the queue, there is no element to be inserted. Thank you.